Alright, welcome back here. We're going to take a look now. We're going to use our calculator to help us to graph move that a little bit. Negative 1/2 sine pi x plus pi. Okay, negative 1/2 sine pi x plus pi. But let's think about this analytically first. Okay, first of all, you know how y equals a sine bx minus c plus d, right? So you're thinking about, let's think about first of all our amplitude. Our amplitude is the absolute value there, that negative 1/2. So our absolute value is a half. Now the negative there, that's also going to reflect that thing about the x-axis, right? Just going to flip it over, okay? Let's think about our period, 2 pi over b. How big is our period here? And our b term is that right there, right? Pi. So we got 2 pi over pi. So our period here is 2, just 2 units, period, okay? So if we're drawing this thing, okay, we're going to go as high as really only a half. So let me make that 1, negative 1. And then our period ends up being 2. So if I was to divide this into equal parts, I'm thinking, well, it should repeat every 2 units here. Okay, so I'm going to probably go by 1/2, 1, and so on, 1.5 and 2. Okay, to divide that. This would be negative a half, and so on. Okay, but now how you can think about plotting some points and getting some key areas is you got to always revert back to, in this case, the sine function, right? Negative 1/2 sine. So you're thinking about the sine of x. Okay, so if you're thinking about the sine of x, so you think, well, when I plugged in and I took the sine of x and I went sine of 0, and I knew that the sine of 0 was 0, right? I knew that the sine of 0 was 0, right? And so if you think about that, and you got this function, negative 1/2 sine pi x plus pi, right? Okay, so you're thinking, well, if I can get that pi x plus pi to be 0, this will give me a nice point here that I can look at. Where is pi x plus pi equal to 0? And you solve that, right? Divide by pi, negative pi over pi is negative 1. So you say when x is negative 1, right? I'll just plug it in for you. So pi times negative 1 and then plus pi. So you see how we have sine of negative pi plus pi here? Or in other words, sine of 0, right? And what's the sine of 0? Well, it's 0. So I got negative a half times 0, which is 0. So my y value is 0. So I know I have the point negative 1 comma 0, right? Negative 1, because that's what I have to plug in for x. Oops, that's negative a half. Hee. There's negative 1. Okay, remember this goes by 1/2 here. Okay, so let's go to another key point on the sine graph. And I say, well, you know how a lot of the time we'd go and we would get like pi halves. We get a maximum value as sine of pi halves. It would spit out 1, right? So what would happen where, so again, I'm thinking the old original sine pi halves, that would spit out 1, right? A max value for us. So what about if for this one, where is pi x plus pi equal to pi halves? So, well, let me subtract pi, pi x equals negative pi halves. Let me divide by pi, so I got x is negative a half. Well, I probably could plug that in anyways, right? Because I know it's divided into 4 equal parts, so it goes by 0.5 each time in this case. So negative a half would be a really nice point to plug in. Let's see what happens. Remember that this thing actually flips it over. So if you're plotting that point, negative 1/2 sine pi x plus pi, negative 1/2 sine, pi times negative a half plus pi. So I got negative pi halves plus pi is pi halves in there, right? And we know the sine of pi halves is 1, negative a half times 1, negative a half, right? So at negative a half, it spits out negative a half, negative a half, negative a half right there, okay? If I plug in 0, what's going to happen? Well, let's plug in 0 now. I gotta get rid of some of this stuff. Okay, let's plug in 0, 1 half, 1, so on. So of course that's 0, right? So we just have 0 plus pi. Negative 1 half sine 0 plus pi sine of pi. We know that the sine of pi is 0, so negative a half times 0 is 0. Okay? We plug in 1 half. Alright, what are we going to get? Well, we plug in a half. Pi times a half. 1 half pi, or pi halves plus pi. 3 pi halves. And we know that the sine of 3 pi halves is negative 1. So this part is giving me negative 1. Negative 1 times that negative a half in front is positive a half. So 1 half comma 1 half and so on. Anyways, we plug in 1, we get pi times 1 plus pi, that's 2 pi. Sine of 2 pi is 0. Negative a half times 0 is 0. And we could keep going on this thing, but I'm satisfied for now. You know, I know that this thing right here is going to give me that negative a half. You know, at 1.5 it's going to give me negative a half. At 2 it's going to give me 0, and so on. Okay? Alright, because my amplitude's a half, my period's 2, and can you see the period here? There's our period. It's just 2, not 2 pi, right? 2. Okay. So we've kind of analyzed the graph of this thing, and you're probably wondering, didn't you say you were going to do this with a calculator? I did, but that is how you would approach it by hand if you were given that. Let me grab my calculator here. Let's see. Okay, so we had negative 1 half sine pi x plus pi, correct? Okay. Negative 1 half sine pi x plus pi. Now, I'm in radians, okay? And now I'm going to go F2 zoom, and I'm going to go down, and in this case, I'm going to stay actually zoom standard, because if you remember, our period was 2, not 2 pi, okay? So I want it to show, you know what, let me change my window a little bit. Let me change that. Let's go from negative 2 to 2, and let's have each scale be a half. Negative 1 to 1. My scale will be a half on that. Let's look at this now. Graph that a little better here. Okay. And I can go trace, 0, 0, yeah. 1 half, 1 half, 1 comma 0, 1.5, 3 halves comma half, so on, 2, 0. Anyways, we can see that, okay? Now, a lot of time, let me show you just, there's a zoom trig function. So if you were ever graphing, let's say we wanted to graph just the old sine function. So sine of x, I'm in radians right now, right? In radians, so go zoom, and the zoom trig is really nice because it graphs it just like I did on the board when I first introduced this, where each scale mark is pi halves amount. Okay, so if I go trace here, 0, enter, and I'm like, let me show me the pi halves one. Pi halves, comma 1, so I'm going to trace pi halves, comma 1. Let's check 3 pi halves. 3 pi halves, make sure you put that in parentheses there. 3 pi halves, enter. negative 1. You see that? 2 pi, 0, and so on. Okay, so that zoom trig is typically what we're going to use. That window is typically what we're going to use when we're graphing. Okay, it's nice when your periods are, like pi halves amount, or you want, or I'm sorry, your each scale is about pi halves amount, or what have you. It's involving pi. So zoom trig. Okay, zoom trig on that one. Okay, let me go back over here. Let's do another one of these. Let's consider, oh, there's one thing I forgot to mention here. Okay, some key points here. What are some key points? Like your x-intercepts, right? What are your x-intercepts? Well, you got your negative 1, 0. Notice your 0, 0, right? You could name all these. Your 1, 0, and so on, right? 2, 0. What's your y-intercept? You know, it's your y-intercepts right there, 0, 0. Okay, it's the origin in this case. What about your max values? Your local maxes, you see there's one, right? It looks like I showed. The next one's going to be right here at 2.5, right? So like 1 half, 1 half, comma half, 2.5, comma half, and so on, right? Our mins, got some mins here. Okay, so these are some key points. Negative a half, negative a half. You got this other one, what was this? 1.5, comma, negative a half, and so on. Okay, so keep those in mind when you're graphing those key points, but make that a little more explicit there. All right, so let's use that calculator again at the end here to graph, analyze this 2 cosine of x minus 5. Okay, so we're going to start out again. We're going to say, you know what, my amplitude is 2. Okay, so we're going to have a little vertical stretch here. That minus 5 tacked on to the end, right? That minus 5 on the end, that's going to vertically shift down 5, isn't it? Okay. Our period is 2 pi over b. Our b is 1. You see the 1 right in front of that x there. So we got 2 pi over 1. Just 2 pi. Okay. So when you're doing this, which function you're thinking of? The parent function. You're thinking of the parent function cosine of x, right? So you know that the cosine, let's plug in 0 again. Oh, and I'm sorry guys, your period's 2 pi here, so let's split that up again into 4 equal parts. I like to do it that way. So in this case, we're like, okay, pi halves pi with typical 3 pi halves 2 pi. Okay. Okay, so let's plug some points. So here we go. 2 cosine, agree, 0 minus 5, and I say I know the cosine of 0 is 1, so I get negative 3. 0 comma negative 3. Okay, let's go pi halves. Let's say the cosine of pi halves, 0. So 0 minus 5, negative 5. Pi halves, we got negative 5. Okay, pi, cosine of pi, negative 1. 2 times negative 1, negative 2. Negative 2 minus 5, negative 7. So pi negative 7. And remember, we've taken this cosine function, which was kind of revolving, sort of, if you will. This curvature was around the x-axis, so we moved it down 5. So maybe if you want to think about, hey, I've moved that down 5, I'm going to be going about that, right? Now we're plugging in the 3 pi halves. Well, the cosine of 3 pi halves is 0. 0 times the 2 in front, 0. 0 minus 5, negative 5. So 3 pi halves, right there, negative 5, okay? You kind of see this thing. Oh, yeah, okay. And then our 2 pi, cosine of 2 pi is 1. 2 times 1, 2. 2 minus the 5, negative 3. So went back up here to this negative 3 and so on, okay? You know, negative pi halves, we're going to be at negative 5, negative pi, we're going to be at that negative 7, and so on, okay? All right. Now, can you see our period here is 2 pi? And, you know, you might even think about it going from here, and I repeat this pattern again, don't I? After that, if I repeat it in green, it's going to repeat that same pattern down and up again, okay? But anyways, that period there is 2 pi, isn't it? Okay, you got your max values at 0, negative 3, 2 pi, negative 3. Okay, here's our maxes. Okay, we got a min there, pi, negative 7. Pi, negative 7. The next one, of course, would be at like 3 pi, negative 7. That's a min value. Let me circle that in red. There's a minimum. You know, there's no x-intercepts. There is a y-intercept is 0, negative 3. Okay, domain, all real numbers. Range would be from negative 3 to negative 7 there if you're writing that in interval